Alright guys, in today's mini lecture we're going to discuss how to identify and what is paramagnetic and diamagnetic. First of all, in chemistry in the AP level, we often will go through and talk about the exact same concepts that we covered in general chemistry have new terminology, and that's what we're dealing with. So magnetic basically is talking about how an element or a compound will either be affected or not affected. So let's go through and look at, first of all, what is paramagnetic versus diamagnetic. So paramagnetic in an element means that we have valence electrons that are not paired. And then in diamagnetic, we have valence electrons and they're all paired. So let me go through and give you an example of this. I chose oxygen. So when I draw oxygen out, and I'm going to draw its orbital diagrams, I will get a 1s2. That's where we start. Both of them are paired. Then I get a 2s2. And again, both of them are paired. Then I get a 2p, and I only have 8 electrons. So I've done 1, 2, 3, 4, so I only need 2p4. So whenever I make this into my little orbitals, then I know that my electrons are going to go into those rooms one at a time before they start filling them up. So I have 1, 2, 3, 4. So do you see how I have these 2 electrons here that are not paired? That's it. So this would be paramagnetic. What does that mean? If this was going through a magnetic field, because it has these unpaired electrons, it would be affected by that magnetic field. All right, let's do one that's diamagnetic. I'm just going to simply say 1s2, and that is going to give me those 2 electrons there. Then I go to 2s2. Remember, I'm placing a total of 12, so I've done 1, 2, 3, 4, and if I 1, 2, 3, 4, 5, 6, it's completely full. Everything is paired. I've done 10, so I have to go one more, which is my 3s2. 2 in there, you'll see that, yes indeedy, this orbital is completely full. I have no unpaired electrons, so therefore everything is paired up. As it travels through that magnetic field, then it would not be affected. So this is how you look at individual elements. But we also need to look at compounds. So in our compounds, we're going to have to do our Lewis structure, and that's what comes in with today. And we are going to practice drawing the Lewis structure for NH3. So first, I need to know my total valence electrons. So my nitrogen has 5. 3 more gives me 8. So when I draw this, I'm going to put an N. I'm going to hook up a hydrogen to each one. So that's 2, 4, 6. So that leaves me with 2 electrons. Now usually anything that's left over I put around my peripherals, but since this is hydrogen, we know that it is satisfied with the duet rule, and that shared pair of electrons, duet and duet. So everything is good with them. So these last 2 electrons are going to go around my nitrogen. So now I do make sure it's all at the octet, 2, 4, 6, 8. That is my drawing. Now when I look at this, do you see how my central element has a lone pair of electrons around it? Right. So not only is that going to influence the shape of it, that's also going to influence whether it is paramagnetic or whether it is diamagnetic. And in this case, lone pairs of electrons, as this compound goes through a magnetic field, those lone pairs of electrons, even though there are 2 of them, it's a lone pair on a compound electrons anymore, then it would be affected as it goes through the magnetic field. Electrons, so I have 4, I have 8 again. This time I put an H, all up, I have 2, 4, 6, 8, so I don't have any left over. Duet, 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 duet. Hydrogens are all good. 2, 4, 6, 8. Carbon is at the octet. It's all good. If I look at my central element, see that the central element does not have any lone pairs of electrons. Therefore, it is considered diamagnetic. Means that it is not affected as it goes through that magnetic field. So, paramagnetic and diamagnetic basically is referring to two things. If it's an element by itself, it's the paired or not paired electrons. If it's a compound, it is the lone pair of electrons or not a lone pair of electrons. And all of this has to do with how it behaves as it goes through a magnetic field, or we can use the word polarity. Hope this has helped you.